This is the freshly released version we just completed today. It's the latest version launched today. We're now at version 1.992. Let me demonstrate how it works. First, I'll show you its appearance. Once set up, this is what you'll see. Upon first entry, you'll need to log in. After logging in, you'll notice this icon. It displays your name. Log in with your existing IVX account. You can either log in or register a new account. This version is in English. Later, you might need to enter your large model key. We currently support many large models. We support most major models, both domestic and international. However, the best results come from the first two. Especially with the first ones, consider the cost effectiveness. Anthropic's cloud is top-notch. There are also advanced options available. OpenAI's GPT is certainly among the best. We can support all of these. As for the rest, they're domestic like your DeepSeek, Kimi, and the latest Minimax 3M. And Qianwan, all of these actually work. There's also a very affordable one that's quite good. It's the Chennai 3.5 Flash, and it's free. Once you're done, you can enter these keys here, and they'll be saved for you. So mainly, it's just the others. There's nothing particularly special to configure. Okay, once you're in, you can type here, stating what kind of website you want to create. I'll demonstrate for everyone later. First, let me show you the final result. This is how it looks. Actually, it turns out like this. Yeah, take a look. This window is actually a chat window. It's an AI chat assistant. It controls the generation of all these elements. So how is this generated? Actually, we have something here. Let me explain. There's a flow. Let's examine this flow. This flow resembles a flowchart, but is much more complex. Technically, it's called a DAG, a directed acyclic graph. All AI generation paths, including AI control, are executed through this complex graph. It can be very intricate. See here when we click on it. There are various types of these graphs. Some manage generation. Others handle tasks like cloning, such as duplicating a website. You can also make adjustments, perform automated testing, or debug. All these processes utilize this graph. In this generation section, we can explore more complex examples or discover some cloning scenarios. For instance, let's examine cloning. It might be slightly more intricate. This one is simpler. All right, then this is generated. This is designed for enterprise use. Then it operates according to this. It executes node by node. I still need to run it, and once it's complete, finally it generates. This file here is a VL file. What is a VL file? It's actually our new programming language. A new programming language. You can see it here. This is our proprietary programming language. We've tackled the biggest challenges in AI today. There are two main points. The first point is current AI solutions address problems in specific domains, like within this scope, a particular issue, for example. I input a lot of data, then give it to AI, and it returns the result. It's actually hard for humans to surpass this because that's how it's trained. However, if you really want to tackle more complex problems or certain real business tasks, it's all a process. First step, what to do. Second step, what to do. And then you need people to connect all these steps together and solve the problem. Of course, this is still linear, but it actually demands a lot from people. That means everyone might have different capabilities, and their ability to handle AI can vary greatly. So we actually level this out because through this workflow, we can harness AI within this workflow to keep it on track. We define what each point inputs, what AI should do with it, and after it outputs, what happens next, and then what, and what AI does again. And then through a diagram, we consolidate all this logic into one diagram. Or you could say some programs are also consolidated into a diagram. Now, this diagram is generating this workflow for our application. So in the future, it can manage various workflows. And then through this method, we take this and solidify it. Then the app you create will be more stable. It's like it provides you with the entire process, analyzed and linked together. Then you just need to run it. And it should basically be correct. Okay, so also our code is actually our own language. This language is highly structured and fully layered. Now we're generating other things. So it will execute these things. Okay, let's briefly introduce this panel. So after we automatically upgrade over there, we come over here and then you can start debugging. For debugging, here we have a tree. This tree is called the object tree, representing each object. Everything here is componentized. Everything is a component. And this tree here is the file tree. There are a few important points here. First, everything is componentized. And actually, during AI usage, it can dynamically, for instance, when I'm generating, it can dynamically pull components from our platform. We currently have nearly 20,000 components. In the future, we might expand to 1 million or even 10 million. The real value lies in effectively storing the current AI computing power. There's a misconception that companies like GPT and others focus solely on computing power, stacking GPUs, and even building power plants. In reality, this computing power can be stored. For example, our method can effectively store computing power within components. With enough components, all that compute power can be stored. This allows you to generate an app in seconds or even faster. Not only is it fast, but it also saves money since the compute is already stored. You might not need as many GPUs, and those can be used for complex problems or new challenges. From a top-level programming perspective, once everything's stored, building apps becomes incredibly simple. No need to redevelop or brainstorm immediately. Just store it. We've effectively utilized all this, integrating it into our programming language to solve the problem. All right. Of course, you can click to explore. There's a lot of interactive behavior here. It's reminiscent of what we used to have. It's like a world panel. You click here to select and edit. So here, besides our own programming language, you don't need to learn any other programming languages. You can view this. It's entirely graphical. You can express all the logic through graphical means. Whether you click here or there, it's the same. You can select it. These are the back-end logics. And those are the front-end logics. Then you can do all sorts of previews. For example, you can preview the entire page. This type of preview is quite satisfying. So everything is visualized. Everything is componentized. And you can also code. Of course, we primarily designed this language for AI, but it's also easy for people to learn. At least it appears simple. Once you're done with this, you can actually do linting. After compiling, you can view the preview results here. Let me show you. Once you're done with this, you can actually do linting. Then go for pre-compilation. After compiling, you can see the preview results here. Let me show you guys like this. This interface is slightly larger. All right, this connects to the previous section. Trim off some earlier differences. Then this part enters its complete generation process. Regarding the generation process, there are two windows here. One is the main window. In the main window, I write a requirement and it starts generating. Every step is documented. The other is the log window. The log window contains all the details. Everything is here. It shows which model is running and which node it's on. How much time I spent generating how many tokens. All this is recorded here. Then we can take a look. Here, it will jump around, indicating it's now on a certain node. It's automatic. Once selected, it will enlarge. It focuses only on the current main node. Everyone knows you just regenerate here. These represent the current running processes. It's generating now. After it's done generating, it automatically forms the entire VO application, and then it's complete. So you just need to watch this, wait for it to finish, and that's it. It will automatically perform some checks and inspections, ensuring the application is correct. Of course, after it's done, you can manually make some adjustments and make some manual corrections. For example, adjust the interface visually for me. You might adjust it faster than it does. You can quickly change a color or something. Just edit directly in the visual interface. Okay, that's basically everything. It's divided into sections, which we've explained. Workflow is a very important part of it. We use this workflow to manage the entire AI-generated application process. Once the code is generated, it's our own code. It compiles into the target application. Then you can publish it, put it on a website, or you can use it locally later. Both work. That's basically the process. Thank you all.